Good morning, ladies and gentlemen. My name is Kenji Rikitake, and this is actually my 5th year to be here. And my ID is right here, some kind of cryptic string, but this is actually my ham radio call sign. And if you have difficulties on finding me on the internet, just Google my name. Then mine will be coming to the top. All right, I'm going to talk about Star Trek game. Star Trek game. For the first of my talk, I'm going to explain something about the Star Trek and the history, and I'm going to talk about how to porting it to Lua, and explain why Lua is related to this topic, and remaking it for Erlang. And I'm going to explain all the pitfalls and things I've learned. Then I make a very small demo. And to conclude this session, I will give you future plans and references. Okay, this is a BSD track. BSD track is designed designed since 1980, I guess. I don't know. At least in the source code, there's a huge ancestry program in 1970s or 1980s, written in Fortran or whatever. But the game objective is very simple. There are lots of Klingons in the galaxy, and the galaxy stands for galaxy has two-level architecture. Two-level classes. First level is called quadrant, and the galaxy consists of 8 by 8 quadrants, two-dimensional, and each quadrant has 10 by 10 sectors. So each sector is filled by something. The something will be a star, or this enterprise ship, or the Klingon ship, or maybe an inhabited system, or black hole, or just fairly empty, was shown by the dot. And the game mission is simple. The Enterprise beating all the Klingon, wiped out all the Klingon, and the remaining number is 0. If the remaining number is 0, Enterprise wins. And if Klingon depletes the energy of the Enterprise below 0, Enterprise loses. That's the very executive summary of Star Trek game. And to tell you the truth, it's all text. It's just scrolling down and up, no curses, nothing special. So, but I think this is I wanted to for the re-implementation this Erlang, I want to preserve this to this because I just wanted to be that way because that was what I was playing in my early childhood for 30 years ago or so. So, right, then why Star Trek to choose about for our topic? It's small and easy to understand. Small means small in this today's computing environment. Now we have gigabytes. Now we have a whole lot of memory, whole lot of gigahertz CPUs. For those CPUs, Star Trek is a very tiny game. But remember that the original Star Trek was developed in 1970s, where the RAM of getting 1 megabyte of RAM is very precious, and maybe 10 megabyte of hard disk was very precious. So it was very small, and so the design is small and concise, and it's very easy to understand. And of course, it's well known, at least since 1970s. And if you don't know about this game, ask the old people like me around you, and they will tell you lots of anecdotes about the old Star Trek. And there are many implementations. You can click those underlined stuff in the further presentation PDF, which I've already passed on to the Erlang solution staff, and they will make it public. And the first implementations were all in Fortran or BASIC. Those are very old language. And there's a much modern networked game called erltrek. I've never played erltrek, but the erltrek is somewhat has still something to learn or look up, something to look up, even in the age of 2014. And recently, I've discovered there's an Android app for Star Trek in the old text style. So you can try it if you have an Android phone. And I think I've never checked it. There might be iPhone Star Trek. But the most important point is that I couldn't find an Erlang implementation. Nobody did it on Erlang, and that was the ultimate incentive. I decided to do this for this presentation. So then why I chose BSD-trek? BSD-trek is written in ANSI. It's C90 or C88 or something. It's not even C99. And the code is frozen in 1993, although I recently found a bug. I don't know how or who I should report it, but I found a bug. But anyway, it's code for mostly frozen in 1993. And it's still playable of FreeBSD, and that is good. And it's part of a Dragonfly BSD, another BSD software distribution. And it's comparable on this machine I'm in OS X without modification. So it's very well written. And the original Star Trek is just a fighting game of firing each other and just that. But the BSD-trek has other interesting features, such as internal, very simple event queues, which you can set the time bomb event, like some star will go into a supernova and contaminate all the quadrant, and you cannot go in, or otherwise you're going to die, or something like that. But that will happen in a timer queue-based data structure. And this is very simple, but kind of something you can learn to implement some sort of asynchronous programming. And it's obviously BSD licensed, although it's University of California, Berkeley licensed, so it has another clause that don't use it for advertising or something like that. But it's still BSD licensed. And I've been doing the BSD for more than 20, how many? I don't know. More than 24 years, so I love BSD, so period. So let me talk about what I have done. Of course, I had to read the source code in C. And I'm not going to talk about this in details, because you got to read it. You got to read the source code anyway. But I'd like to introduce one very good tool to read source code in C. It's called GNU Global, G-L-O-B-A-L. GNU Global is a kind of an analyzer which makes a detailed cross-reference of each variable, each function, and each data structure referred to what kind of source code in the project. And you can put it as a set of the HTML file, and that is very good because you can browse it. You can browse it. You don't have to use the editor. Of course, you can call it from Vim or Emacs or whatever editors, but GNU Global is a very good tool to read in C. So I sure do recommend it. And after doing that, I port it to the Lua just to read the source code. Why porting it? Because I really wanted to read the source code from the beginning to the end. But I just don't want it to report it to C, because I don't want to allocate the memory and freeing the memory and going the memory leak bug. And I don't want to deal with the notorious go-to-fail bug recently revealed by Apple. And the Lua is much better in many sense. It's more modern. I'm going to explain a little bit about Lua in this presentation. And last, and I think this is the most important part, I redesigned it in the new track in RNOTP. It's still work in progress. I'm sorry, it's far from complete, but it's still work in progress, and I had to do it last week, in 1 week, and I could successfully implement the basic functionalities over there, and I'm going to explain it further in this presentation. So why Lua first? I repeat it. It's small and easy to understand. The author of Lua claims Lua can be put in a floppy disk. Floppy disk. Who cares about floppy disk? But it's less than 1 megabyte. Less than 1 megabyte of the whole source code. It's very important. Not so important on the modern laptop or even modern Android or that kind of a resource, those environments and plenty of resources. But it's very important for a resource constraint environment. And the syntax and semantics are like C, but better. I mean, well, better has a lot of meanings. For example, Lua has no pointer. So you don't have to deal with the structure pointer operator or something like that, like in C. And Lua has a more concrete syntactic structure, so you don't have to write something like go to fail. But unfortunately, Lua is still based on a shared memory programming model, and that is sort of inevitable because it's running on a memory constraint environment. And Lua is also popular among game programmers. I'm not so familiar with the gaming people's world, but I've heard a lot of stories that to use Lua as a configuration language from the C program, and you can pretty easily go back and forth between the C world and Lua world. And so that's another advantage of Lua. And it has a very simple data structure. The Lua's advanced data structure is solely based on the key value tables. Key value table is the only advanced data structure Lua has, and Lua does everything on it. And the philosophy is very concrete, easy to understand, and it's something resembles like Bash's React. I have to show you a disclaimer that I was a former Bash employee, so the React was pretty familiar to me, and the whole notion of key value store is very easy to understand for me. And it's garbage collected, as in the modern language, so you don't have to think about the memory allocation control. And I'd like to tell you that Robert Verding even implemented Lua in Erlang. Lua in Erlang, not Erlang in Lua. Lua in Erlang. So, and his implementation of Lua is very sort of crazy one because he implements Lua's every state as a part of the Erlang variable. So he can make a concurrent Lua processes in Erlang Beam. If you want to take a look, you can click this in my presentation slide later, which will be distributed to you. But it's called LuErl, L-U-E-R-L. And maybe Robert Verding will kindly answer to lots of questions about why he does it. It was 2011 when I heard that story. So back to Star Trek. This is what erltrek is all about. You will see very little difference from the BSD track. But the difference I put is all over here. It's like Klingon, number 1 did not move, or escape to quadrant 2.0, or moving to something, and the new data structure is something like that. And this is a very typical printf debug. Because there was a very nasty bug in Lua, or better say in BSD-C track, which manipulated the boundary condition of for statement inside the for loop. If you read the C language specification, this is valid. But if you are going to write a code, something like that, this will clutter the whole stuff because the thing because if the ending value, if the loop is beginning from 1 to 4, and inside the loop, if the end value is going to change to 3, what will happen? It's very hard to understand. This is because the for loop C language was just another syntax sugar of while loop. But in Lua, things are different. In Lua, all the boundary condition is pre-calculated before the whole loop is executed. So if you make a loop of loop variable x from 1 to 5, the 1 and 5 are fixed values. You cannot change it in a loop. So you cannot directly translate C into Lua. So it's really a nasty bug I had to deal with. I hope in Erlang this kind of thing will not happen. But some people say procedural languages are all the same, but that is not the case at all. You have to really take care of the semantics in the very details. Okay, let me talk about good things about Lua. The tables are very good, very well designed. You can use numbers, of course numbers, and strings as the key. So the module you can get access to the table member. Just put the dot and the member name to the table after the table. So you can treat tables like something like an object-oriented or better say hierarchical naming system of a module. So the Lua module system is implemented just on the table, and it can also be handled as sparse arrays. I mean that if you make a 10,000 by 10,000 array and just fill in 1 or 2 actual members other than the default value, Lua will not take more than 2 or 3 or somewhat like actual memory objects. And let me emphasize that in Lua or modern languages other than C will be more free from the go-to-fail, the fiasco that Apple made recently. Lua only allows strict if-then-else or if-then-else-if, else-if blocks. And it's quite simple. The control structure is quite simple. But on the other hand, Lua has no switch statement of C, and Lua doesn't have a continue statement either. So in Lua, you should use go-to statement effectively. So you don't have to think about the go-to fail mistake, but you have to think about go-to in Lua too. And it's semantically simple, no malloc-free, malloc-free or memory allocation, and the table constructor is like an Erlang tuple. If you make 1, 2, 3 like this, that will be a 1, 2, 3 table. With the first element with the key 1 will be 1, then the key 2 will be 2, and key 3 will be 3. But okay, before saying but, I'm going to explain the Lua source code. This is Lua source code, a part of my erltrek source code. And it's not Erlang for one obvious reason. This stuff. It's x equal x. It's a semantically same as x equal x plus 1, which prohibited in Erlang. So it's basically a shared memory, or assignment is shared memory and traditional assignment language. So don't misunderstand that Lua is something like Erlang. But I should say that the rewriting all stuff from C to Lua was very educational to me, because that removed the whole prejudice of mine of the JavaScript or other procedural language, modern procedural language from the C. Okay. All right, but Lua, there is surely a bad thing about Lua. You see this. You make a table called A is 1, 2, 3. And if you print, if A equals 1, 2, 3, that should be true. But on Lua, this is false. Why? I once saw this. I once experienced this. I thought I was sure. But on Lua, every table constructor makes a different table. And the Lua variable only holds a reference, the address of each table. So the if A has an address of 0x1234567 then this 1, 2, 3 would have an address of 9abcf or something like that. And so this one and this one will not be the same at all. This is the language, default language specification of Lua. And I complained about this on Twitter. And one of the kind gentlemen or gentlewoman told me that comparing two tables need to be explicitly done by an external program. And on Lua, you can bind it in a table called facility called the meta method, but that is not a default method. So this is, I think this is a sort of problematic behavior of Lua. And on Erlang, now Erlang, sorry about waiting so long time, but now Erlang, it's not that bad. 1 to 3, if you say 1 to 3, you get 1 to 3. And if you try to compare A equal 1 to 3, it's true. Yes, true. Why? Why? Because it's on Erlang, in a very hard-to-read manual, as Dave Thomas said in this keynote speech, there is a clear definition that on Erlang, if you compare tuples, two tuples, all members and all structures are thoroughly compared. It is well written over there. So the two tuples are compared in full complete details, and so they are considered the same. And I think this is how it's supposed to be. So I'm not saying which language is better or not, but for me, Erlang is a little bit understandable than Lua in this sense. Okay, there are many other port kabits on Lua. After all, it's a sequential game. It's like an original Star Trek. The game program will wait for your input forever. And it's very hard to debug because the game state is manipulated in so many different places. It's a pattern of the shared memory programming. If you put the game state in a set of shared tables, you have to touch it by the many kind of modules or many kind of functions. And the relationship of each function is not necessarily obvious or apparent. And the problem is that everything is in the shared table. And you have to suffer from the shared memory-based programming. It's really impossible to make it asynchronous without rewriting it completely from the scratch. So I decided to redesign the game in Erlang OTP, and I made some goals first. Make it real-time. Real-time has a lot of different meanings, but in this time, real-time means that the game events will happen even without the user input. For example, if you are staying in the quadrant with the Klingons there, Klingons will be firing at you even if you're doing nothing. And I will show you it later in an actual demo. But then on the C track or Lua track, that doesn't happen. It's a pity, but that doesn't happen. And I'd like to get the most out of ODP library modules. Whether it's easy or hard to understand, ODP has lots of good things. And I am a conservative person, so I didn't try the maps of R17. But DICs are basically formal maps, or better say maps is something like dict. So if you write something with a clear understanding of dict, you can convert it to the maps later, I think. So it's built upon R16b03-1, the last release of R16, and which is still the official release. And I'm repeating, maybe I'm repeating this too much, but I'd like to keep the original look and feel as they are, because I really like it. But I want to make it more logical, because for example, in the C track, when you leave the quadrant, and when you re-enter the same quadrant, the stars will not be in the same place. This is ridiculous, because in C track, the whole sectors are recalculated. the whole stars are placed randomly. The it only remembers how many stars are in the quadrant. It doesn't remember where they are. So in my version, I put the whole star's position pre-calculated, so that when I go out and go into the same quadrant, I can see the star's position in the same sector coordinates. So let me talk about the data structure. ODP has plenty of nice libraries. It has a sparse array. Sparse array means arrays with default value, for example, 0. And when you add some elements in the array, it's actually represented by the whole lots of the tuple trees, whole very large tuple tree. But the things will be changed only for the non-default value elements, so it's very efficient. If you have time, dump the content of the array object, then you will understand how it is implemented. And there's another very small data structure called OLDICT. It's a ordered dictionary, and it's actually a list of tuple, of the 2-element tuples. And you can use this for a very small conversion table, such as converting internal atoms into the external representations. And let me talk about DICT. DICT is about table. It's a key value store. A very simple key value store filled in element structure. I mean a huge amount of tuple. It provides a basic function of table. And you can add multiple values in the same key, and that is good. And if you don't know about the DICT, I suggest you to take a look at it in a manual, and you just play it around, because it's so easy to use and so versatile. And I made the whole internal data, most of them, as DICTs, such as quadrant positions as keys, stars, inhabited systems, black holes, star bases, and the number of Kringans. And I wrote here that maybe maps soon. Maps soon means that maybe I can convert them into Erlang maps, so that Erlang maps would be more lightweight than DICT, so that easy to run, and may gain some sort of performance increase. And for the current sector means that where enterprise, a sector or quadrant where enterprise resides. I made an array, which means pseudo two-dimensional means that the array itself is one-dimensional. So when you make it a two-dimensional, if the array size is 8 by 8, and x and y, you make an array subscript or index of x times 8 plus y or something like that. It's simple. It's simple, and it doesn't take much to compute. But anyway, I implemented it as an array of the entities, and I also made a dict of Kringans data in the sector. For the current implementation, it only has how much power Kringan remains. But you can put many other information as a form of tuple or whatever. Okay, so I also made records for the structured data definitions, such as a record for the enterprise position, the enterprise how much energy remains, or enterprise how much shield energy remains, or what kind of command enterprise is executing right now, because I made it concurrent, so that somebody has to remember what enterprise is doing for the given time, given tick time at the time. Yes. So, okay, let me explain some fundamental difference between the shared memory data structure way you're programming and the Erlang Gen server way you're programming. On the shared memory, this is a typical DICT structure. I put it a quadrant and sector position of stars. lots of functions are trying to get access to this same memory in an arbitrary sequence. So if two functions are trying to write the same position at the same time, the result is unguaranteed. The result is not guaranteed at all. This is a traditional problem of the write conflict. And so long as you are doing this with a shared memory data structure, there must be some way of these functions to communicate with each other to prevent write confliction or even read confliction if each function locks the record of each entities, which is not possible on the dict structure, but may be possible on the ETS, I mean the earned term storage structure in a more complex program. So on programming a Gen server-based system, you have to change your mind completely inside out. Think about state first. These are equivalent to all the dict tables. And when you do something, you filter the state into the function, and it's going to be a change state. And you do it again. Maybe in this function, a Klingon will be killed, so that in this state, the number of Klingon will be decremented by 1. And in this state, a Klingon will attack you, so that the energy of enterprise will be depleted in some value. And every time you change something in the game, you have to change the whole state. This is cumbersome, and this is kind of hard to understand if you don't have the clear view of the whole game state or whatever you want, what kind of the internal state you have to deal with. But if you have the firm understanding of the game state itself, this is not so hard operation. And I think this is one of the most difficult part of the programming in the programming with the Gen server behavior. Okay, so let's talk about the Gen server. Gen server is, I'm not going to get into the details of Gen server. Gen server stands for generic server. It's a part of the OTP, and by using the Gen server, you can split the server generic part and the server specific part in two programs. And I'd like you to take a look at the manual or the OTP design principles for the details. But in my program, what I do in the Gen server is to handle the timer event as an info given into the Gen server. I use a timer of 1 second for ticking the clock. Ticking means incrementing the clock value by 1. This can be handled in Gen server in a very concise manner. You just give the Gen server output from a timer, and if the output is coming to Gen server consumes it, and Gen server recognizes it, and it will process the whole timer dependent events, and the Gen server will issue another timer of 1 second, so that the timer loop will continue and continue and continue forever as long as the Gen server is alive. And you can use Gen server for process call requests with replies, like starting the game. I make a very small function called start game, and when you start game, the Gen server will initialize the whole state and then give you back OK, so that so that the Gen server tells you that the game is playable. And you can use this for the game, to use the entering the game commands, to move the enterprise or to attack the Klingons or something. And having a reply code is very convenient because if the gen server cannot accept the command for the some reason, such as because of the rules of the game, the gen server can reply with that the command will not be accepted or something like that. And there's another use of gen server. It's called cast. Cast is an asynchronous request to the gen server. So, for example, if you want to terminate the game for some reason, like when the enterprise energy below 0, then the routine can throw the request to the gen server itself that the enterprise is lost, no further game. Then the gen server will immediately terminate the whole server process after doing the necessary job, like printing that U rules or something like that. And the good thing is that you can do these all things in the same server. You don't have to have multiple servers on this, at least for this very slow game. Slow means that you don't have to handle 1 billion requests per day per second. But for the human being, you can handle one or 10 or 100. Those are very feasible in the one single gen server process in the modern computer. So let me summarize the control flow summary. And it's something like this. And this is server process. And the server process handles two main things. Number one, enterprise commands. And number two, timer events. The timer events, it is not handled automatically as another process. When gen server called a timer event, called the external program when the timer event occurs, it will handle the whole timer events in this stuff. And it will cancel the old timer, and it will reissue another timer. So it makes a loop like this. So let me explain some kind of tips on the Erlang OTP gen server. It's all about how input state is going to change the output state. So it's all about state. And you can make some sort of the let's say side effects like printing something or getting access to some external resources. But it's all about state generally. And Erlang expressions always return values, even when the conditional execution is assumed. All conditional executed stuff in Erlang returns values. So don't think in procedural way. Think the returning value is much more efficient way in Erlang. And in this sense, intermediate variables can become often redundant. I have to confess that I'm a procedural way of thinking programmer, so I often use an intermediate variable. But sometimes you can just eliminate the variables, only use once. And always try to use lists instead of loops, especially the number of loops is small, because it's more efficient. And you can make loop or conditional branch as another function, especially to reduce nesting levels. All right, and this is an example of an Erlang code. And it's totally different from the Lua code. And this large brackets are list comprehensions. And I make stuff like lists and pass on to the next program actually doing things. And this hit phaser function is a kind of recursive function. It consumes those three lists and do repeating things until the whole lists are getting empty. And it it does lots of things, but the important point is that when you do the conditional branch, you have to indent the code. So indenting the code, this is so obvious. But if you don't want to indent the code in this way, and then in a very deep nest, in the nested, very deep nest. You shouldn't do that. On the imperative programming language such as Lua or C, this is inevitable. But on Erlang, you can just pass on to the other function if you are going to do the something more complex later, so that the code will be much more easy to read. Okay, I don't know how much time. Maybe 15 minutes, 10 minutes more. Okay, okay. All right, let me do some demo. Right. This is erltrek. It's waiting for my input for an hour, doing nothing. This is BSD track. It also doing nothing, waiting for my input. And this is, I'm going to run an Erlang track. It's called a game. It's something like this, and you have to set the path and run the start link. Start link is the idiom of starting a gen server, and you're going to start game. And I built a module called E because I don't want to enter the long string. So this is not recommended in general programming, but please allow me to do that because I don't want to enter the whole Erlang game something blah 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 enterprise command into stuff. All right. Let's do the game. You're in the own shell, and the game has already started. Okay, let me do this short range sensor. See this. Once again. See this. It's ticking. It's ticking. I know there's nothing special about this. This is too obvious. But for the traditional Star Trek, this didn't happen. It's ticking. So if you are staying in the same quadrant, okay, let me do the long range sensor. And in this quadrant below here, you will find four Klingons in here. So I'm going to move into quadrant 2, maybe on the sector 5 and 5. And in this impulse move, it's ticking. It's in the real time, and its conditions change to red. And during it moves every 1 second. But during the second, you can do many other things in Erlang virtual memory, so the Klingon can think in this time. Although I haven't implemented this, I'm sorry, actually you see this now. Klingon is hitting you, even if you do nothing, and it's still hitting me. It's hitting me, so I gotta fight back. So you show the sensor, and you fight back to Klingon 7, 2 with energy of 200. You shoot the energy, and it's 7 and 2 is still fighting back. So I'm going to shoot it once, and it still doesn't die. So, all right, let me do it once. Yeah, let me do it once. Yeah, it's killed. Yeah, it's killed. Yay, it's killed. Then you still see the sensor, and there are three Klingons, and they're still firing. And the most important point about this is that everything is concurrently, asynchronously done in Erlang in such an easy way. It took me to write in 1 week. So that's the advantage of the programming games in Erlang. The time is limited, so I'm so sorry that I cannot explain it in the details. But if you read the source code, it's not that hard. Okay, let me get back to the presentation. So what I implemented, timer-based tick, as you've seen now, and short and long-range sensor, impulse engines, and attacks from Klingons, and phaser attack from the enterprise. I think these are the basic, very, very basic elements of the game. Of course, we need more. We need warp engines. We need supernovas. We need the Klingons should move Lots of things should be done. I'm sorry, there was no time. That was the lack of my ability. Sorry about that. But you can extend. And the future goals, of course, I need to extend this stuff a little bit more. This is so hard, so far from complete. And of course, fixing bug and refactor code. And rewriting using the maps is surely one of the interesting things from the Erlang point of view. And maybe I can put more asynchronously active entities like Kling and thinking in a more sophisticated way. And maybe you can build a generic API and GUI client. I don't like it, make it too complex, but you don't have to write the whole thing into the standard output. You can just send a message back into some process. This is how things are abstracted in Erlang and what is good about doing all stuff in Erlang. All right, I'm going to wind up. These are the related GitHub repositories. These are all mine. And about Erlang tools, I've written in all Vim. And some people prefer Emacs, but I don't really write editor walls. I use Boss, but for some unknown reason, I just decided to write in Vim. And I think Dave Thomas will complain, but the whole tools I have to use is still in our own documentation and written books. These are very good books. And these are the keywords. Dialyzer and type specs are all very, very important. Even if you write games or even if you write small programs, think about types. Please think about types. That will drastically reduce the amount of nasty bugs in your program. And if you want to see how the process behaves, try using Observer. Or one of my friends, Fred Bell, taught me that use a sys, SYS. SYS module has a lot of goodies also. And if you make something like this, think about using Gen server, not inventing your own. Use Gen server, use JNFSM, use Gen event first. Think about that, please. And on Lua, I will make it brief, but programming in Lua, which is a book written by a Brazilian professor called Roberto Jerusalemski, his book is excellent one to understand how Lua is designed. And there's Lua, unfortunately, Erlang still does not have a package manager, but Lua has a very good one called Lua Rocks. And there's a very good libraries called Penlight and LDoc. These are essential for more modern Lua programming. So for ending the program presentation, I'd like to make some acknowledgments. Eric Coleman, the SendMail guy, wrote this program. And he did a very good job, at least in the 1993. So I have to praise him. And there are three other famous people. Francesco Cesarini, actually boss of this conference, encouraged me to do this stuff. Robert Birding inspired me of using about Lua 2 years ago at the ballroom of somewhere on the 11th floor. And Fred Bell, also about learning from Erlang, told me that this is an interesting project. I think he's doing a track house in the other room today. But anyway, I have to thank him. And Kenji Rikitake, my wife and my partner, suffered a long indifference of mine for 1 week during the. I only talk about somebody is attacking something or somebody is defending or something, and there's a state control or something like that. And she's not a programmer, but she endured all these clutters, and I have to thank her a lot. So thanks. Any questions? Yes.
How long did it take for you to the Google version?
You can find it in GitHub code history, but the number of commits I made on Lua is about 200 or something like that, maybe more, and it takes 2 months because I had no knowledge of Lua. So I took 1 month to read the whole C code and the whole book to understand how the idiomatic data structure of Lua. And I took 1 month to rewrite it from scratch, from top down, testing by trial and error to do write the real stuff. Okay. Right.
Thank you.
Thanks.